Good morning to all. Myself Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, the SAGE Group. Today we will discuss two topics, that is the SMQTT and the COAP. That is inside the subject, that is IT 703B, IoT, Internet of Things of the same SAM. So before going further, we will take a look at what we have done in the last lecture. Here we will discuss that is the application of the MQTT. We have discussed the many more applications in the last lecture, and there are some applications also. That is the Facebook Messenger use the MQTT for online chat. Amazon Web Services use Amazon IoT with the MQTT. Microsoft Azure IoT Hub use MQTT as its main protocol for the telemetry message. Microsoft Azure is the cloud server. The Everything IoT platform uses the MQTT as an M2M machine-to-machine protocol for millions of connected products. And the Adafruits, when you will go through the practical implementation in the Arduino, and when you will install the Arduino ID, then you will be there with the Adafruits for the libraries. Adafruit launched a free MQTT cloud service for IoT experiments called the Adafruit IO. The MQTT features in the MQTT is short form of the message queuing telemetry transport. It consists of three components as we discussed, that is the publisher, broker, and subscriber. It is based on the publish subscribe architecture. Publisher are like the sensor or IoT devices which send their data or change in some information to the broker as per topic. Subscribers are like applications which subscribe with broker to receive change in parameter of a certain topic or sensitive data. These were some features of the MQTT protocol. Now we are coming to the SMQTT. SMQTT stands for the Secure Message Queue Telemetry Transport, is an extension of MQTT protocol, which use encryption based on lightweight attribute encryption. In the MQTT, we have discussed that there was some drawback regarding the security. So here, this is the extension of the MQTT protocol, that is SMQTT, Secure Message Queuing Telemetry Transport Protocol, which use the encryption based on lightweight attribute encryption to enhance the security. The main advantage of the encryption is that it has a broadcast encryption features. In this feature, one message is encrypted and delivered to multiple other nodes. Right? Which feature? Broadcast encryption feature. One message that is encrypted and delivered to multiple other nodes. The process of message transfer and receiving consists of four major stages. How many stages? Four stages. For what? The process of message transfer and receiving consists of four major stages. First, that is setup. In this phase, the publisher and subscriber register themselves to the broker and get a secret master key. That is the first thing. That is the setup. What will be in the setup? In the setup, the publisher and the subscriber both will register to the broker and they will get a secret master key. Encryption, when data is published to broker, it is encrypted by the broker. Data is encrypted in the encryption phase. What we are doing? We are doing the stages in the process of message transfer and receiving. First is setup, in which the publisher and subscriber will register themselves to the broker and will get a secret master key. Encryption, When the data is published to broker, it is encrypted by the broker. That is the publish. The broker publish the encrypted message to the subscriber. Here, the broker publish the message. That is, message is encrypted to the subscribers. Decryption. When the message received, it is decrypted by the subscriber with the same master key which get at the time of the setup from the broker. So these were the 4 stages. Now there are some features of the SMQTT. It is the extension to simple MQTT protocol. SMQTT stands for the Secure Message Queue Telemetry Transport. It uses the lightweight attribute-based encryption. It has broadcast and encryption feature, which does encryption of one message and deliver the same to multiple nodes. Algorithm is divided into 4 parts: setup, encryption, publish, and decryption. Like MQTT, it uses broker-based subscribe and publish architecture. In the setup phase, subscriber and publisher register themselves with the broker and obtain the master key. Before publishing, data is being encrypted. Encrypted data is published by the broker, and when it is received by the subscriber, then it will decrypt by using the same master key but get from the broker at the time of setup. Key generation algorithm is not standardized and depends on developers. Encryption algorithm depends on developer too. That is some that comes inside the feature, but there is no standardized form for the key generation algorithm. That depends upon the developer also. So these were the some features of the SMQTT. Now the another protocol, that is the COAP. Before going further, let's take a look what we have discussed till now. We have discussed the application of the MQTT. This is very crucial part. We have discussed the MQTT features. We have discussed the SMQTT, and we have discussed the SMQTT features. And now we will discuss the COAP. Before discussing, myself Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, the SAGE Group. The COAP, that is the Constraint Application Protocol, developed by the IETF core working group. It is designed for constrained environments based on a REST style architecture. The protocol considers the various objects in the network as resource. First thing, full form Constrained Application Protocol. Developed by IETF core working group. For what it is designed for constrained environments based on the REST style architecture. The protocol considers the various objects in the network as a resource. That is the most important thing. In the REST style architecture, the protocol considers the various objects in the network as a resource. And a URI, that is the unique universal resource identifier, is assigned to each resource. The protocol uses the corresponding URI to operate the different resources. See how many things are here. Full form Constrained Application Protocol. So the COAP protocol, that is the Constrained Application Protocol, it is designed to look like and be compatible with the HTTP. So here we have discussed in the COAP, that is the Constrained Application Protocol, who developed IETF core working group, designed for the constrained environment, based on the REST style architecture, where the protocol considers the various objects in the network as a resource. And there is the URI, that is the unique universal resource identifier. is assigned to the each resource. CoAP, that is the Constraint Application Protocol, has been developed as a specified web transfer protocol for use with the constraint node and constraints network, like the low power network, lossy network. The design goal of Constraint Application Protocol has been to keep message overhead small, thus limiting the need for fragmentation. The communication in CoAP is similar to the client server HTTP, but HTTP has high computational complexity, low rate, and the high energy consumption. These are the some drawbacks of the HTTP. First, that is the high computation complexity, low data rate, and high energy consumption. While both Constraint Application Protocol and Hypertext Transfer Protocol works in the application layer or the ISO mode. The model of CoAP looks more compatible and lightweight. Now, some recap. CoAP, Constraint Application Protocol, Web Transfer Protocol for use with the constraint nodes and network, designed for machine-to-machine applications such as smart energy and building automation based on request response model between endpoint client server interaction is asynchronous over a datagram oriented transport protocol such as UDP. Now, the Constraint Application Protocol is a session layer protocol designed by the IETF Constraint RESTful. So we were discussing regarding the Constraint Application Protocol. So Constraint Application Protocol is a session layer protocol designed by the IETF. And here the RESTful environment, that is the CORE, representational state transfer, that is the REST, is a standard interface between HTTP client and server. Lightweight applications such as those in IoT could result in significant overhead power consumption by the REST. Constraint Application Protocol designed to enable the low power sensors to use the RESTful services while meeting their power constraints. Now, in the Constraint Application Protocol, that is the built over UDP instead of the TCP. That is the main difference, which is commonly used by the HTTP, because the HTTP uses the TCP and has a light mechanism to provide the reliability. In the CoAP architecture, divided into two main sublayers, one the messaging, request and response, and the messaging sublayer is responsible for reliability and duplication of messages, while the request response sublayer is responsible for the communication. So here, the Constraint Application Protocol, that is divided into two main sublayers. One is the messaging and second is the request and response. Messaging layer is responsible for reliability and duplication of messages, while the request and response sublayer is responsible for the communication. CoAP, Constraint Application Protocol, has four messaging modes: confirmable, non-confirmable, piggyback, and the separate. The Constraint Application Protocol is a internet-based client-server model document transfer protocol similar to HTTP. CoAP utilizes the UDP, that is the User Datagram Protocol, and supports the broadcast and multicast addressing. It does not support the TCP. CoAP communication is through connectionless datagram, can be used on top of SMS and other packet-based communication protocols. Constraint Application Protocol that supports the content negotiation and discovery, allowing devices to probe each other to find way to exchange data. Constraint Application Protocols that is support the asynchronous communication, The small packets are easy to generate. Constraint application protocol supports observing resource state changes as they occur, so it is best suited to a state transfer model, not purely an event-based model. Constraint application protocol supports a mean for resource discovery. Now, what is the position of the constraint application protocol? So here, this is the one scenario where the constraint application protocol position is being. We have seen the one the request and the message. The two sublayers were there, and here the UDP and the application. Between that, the constraint application protocol resides. Now, this is the constraint application protocol stack, in which the physical channel, Ethernet Wi-Fi, IPv6, IPv4, and 6LoWPAN, UDP, CoAP messaging, CoAP request response, and application. Now, the features of the CoAP, that is the constraint application protocol features, that is the web protocol, fulfilling M2M requirement in the constrained environment, UDP binding with the optional reliability supporting unicast and multicast request, low header overheads and the parsing complexity, synchronous message exchange, URI and the content type supports, simple proxy and caching capabilities, statelet HTTP mapping allowing proxies to be built, providing access to constraint application protocol resource via HTTP in a uniform way, or for HTTP simple interface to be realized alternatively over constraint application protocol. And it uses for the security binding to datagram transport layer security, that is use the DTLS for the security. So this was regarding the constraint application protocol features, in which we have discussed a lot of features here. And the main thing is that for the security, it uses the DTLS, that is the datagram transport layer security. And these are the references. Okay, myself Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group, Bhopal, welcomes you. Thank you for watching the video. Thanks. Thanks a lot.